Okay, so we're going to make sure the gas is turned on. When it's off, you first walk up to the machine. It was on, but when it's off, you can turn it on, and there's a little ball in there. It'll go all the way top to the bottom and fall back down until there's a gas level. You don't have to completely unscrew this cap. 1 to 2 turns is fine. And then the on button, if it's already turned on in the back, there's a big button in the back that needs to be on. But if it's on like this, and you see a little red light right here, that means you just got to hit that power button. Okay. All right. So this machine is a really, really nice machine. It's got a lot of great features to it. It's set up to run DC or AC, like most TIG welders are. The standout feature on this machine, above and beyond the sequencer, is the fact that you can change the hertz for AC welding, which allows you to get tighter beads on aluminum, and more control on outside corners versus inside corners and flat butt welds. We won't talk about AC welding today. We're going to kind of start off with DC welding, because that is what you'll use for mild steel, and that's what you'll use for stainless steel too. So we kind of go through the features from the left to the right. Polarities first, so you want to make sure that is set to DC, okay? If you're going to weld aluminum, it would be set to AC, all right? So we're going to have DC. Then under our process, we want to specify what kind of process, whether it's high frequency start TIG welding, lift arc TIG welding, or stick welding. Believe it or not, the machine that produces the finest weld is also the machine that will arguably produce the nastiest weld. So any stick welder out there, don't be mad at me because I just said that, but it is the truth. This is like a scalpel and also a bazooka. So you want to make sure that you're under high frequency start. So what that means is it's going to shoot a high frequency arc out the end of this right here. See that little guy? That's the high frequency arc. Okay, little super finger out. See what it feels like? Anybody? It just tickles. But anyway, the point is that the arc, high frequency arc, will shoot out, and then the actual main current will arc through that to get to the workpiece a little easier. The old way you would do it is you would do what's called a lift start. And so you literally have to drag this across the workpiece and lift up and hit the main current, and that would allow the arc to go across. That takes a little bit more coordination. Now that we have high frequency, it helps stabilize the arc at times too. Okay, so moving on, output. RMT standard is what you want, the function you want, so that top LED, we won't get into the functions there. Pulsar is a really great feature, especially if you're going to be working on thin gauge, like stainless steel, for instance. A lot of people like the pulsar. I'll go through that real quick. So pulses per second is what this is. People either go like 1 to 2 pulses per second, and then they jump immediately to like 30 and go from 30 to 40 or higher pulses per second. There's that window between 2 and 30 that will give you headaches and drive you insane, and it's not good. Epileptic seizures, whatever, it's not happy. So usually around 30 is a good starting point. The next function when you hit that button is the peak time. So that stands for peak and time. So 30% of your peak voltage, 30% of the time your peak voltage will be active. So if we go back here and we say 50 amps, and we go and set our pulsar, 30 pulses per second, but if I want to just for talking purposes go down to 1 pulse per second, it's easier to conceptualize this. That means it's going to go through 1 complete pulse cycle in 1 second. So it'll be on and then off, so on at 50 amps, and then at the background current for a little bit. And so as far as peak time, that means that if I were to set this to say 30%, for 30% of that second, it's going to be at my peak amperage of 50 amps. And then my background amperage, 20%, this is set for 20%. That means my background amperage or power or heat is going to be 20% of 50 amps for 70% of the time of that 1 second cycle. So that's how that works. So why all that complicated mess? What it does is allows you more control on thinner gauge materials. don't have that control and you're not really that good and you move too slowly, what will end up happening is you'll burn through the part. You'll just burn a hole in the material. So this buys you a little bit more flexibility, especially for beginners. Also, a good trick is if you were to turn your pulser on to like 1.5 or even say 2, somewhere in that range, and use the pulse to just help you practice your rhythm of dipping your filler rod in. It's like having a metronome in music. It's like tap, tap, tap. And you just like, whenever it gets hot, dip your filler rod in. Whenever it gets hot, dip your filler rod in. Just like so. And I'll show you that. It's a good trick. It's a really good way just to do sort of like repetition. I'm in music, so I do rudiments when I play drums. And, I mean, there's a standard set of rudiments for warming up in music, and that's the equivalent of it. Okay? So all right, so we'll turn that off for now. We'll get into that later. Okay, so after that, we've got the sequencer. All this really is, this is like a program. What you can do is you can program it in to ramp up your amperage and give it more heat in that first second or two of the weld. Then it'll weld at peak, and then when you take your foot off the pedal or disengage, it'll ramp back down slowly. Honestly, you do that with your foot anyway. So unless you're in like mechanized welding, or if you hook this up to a CNC, that's when you would do that, because in the CNC environment, there's no foot control. It's like on, off, right? And so the sequencer would allow you to program in the ramps, constant welding, and then program the ramp down. Okay, so that's really good for CNC welding or repetition. Okay, so the pre-flow, I typically don't use pre-flow, and that just simply annoys me, the pre-flow option, because it won't trigger the high frequency and allow you to start working until the pre-flow time is done. Once you've purged the line and you're welding, fairly often, pre-flow doesn't really get you anywhere. It doesn't really buy you any advantage. I'm sure there are theories that would suggest otherwise and people that would disagree with me, but in practice, it's never really been any more than an annoyance. So I turn pre-flow off. Post-flow, it's set to auto, which is nice. Just leave it there. If you're really concerned about wasting argon, you can you can go to manual. You can turn it off, or you can go to manual and say 1 second, 2 second, 3 second, 4 second. Because it'll be depending upon how hot you're running the machine. Let's say you're running a machine like 180 amps. Your post-flow might be 10 seconds, and you might not need that, especially for mild steel. You might want it for stainless steel, but you just have to kind of ask yourself, do I want it or do I not want it? If you don't want it on mild steel and you're running a water-cooled torch, because let's face it, what cools down the torch, if you don't have a water-cooled torch, is the gas. So you might want it to cool your torch down in a mild steel environment, but since we have a water-cooled torch, we could say just run it for 2 seconds on mild steel, and then run it for maybe 10 seconds on stainless steel. So that's why there's control there. Let's see, we're gonna run back to auto. Okay, so to get back to the main menu, you're just gonna hit A for amps. So effectively, our machine's set up for mild steel and stainless right now. We could go ahead and start welding at this point.